The problem 1631, and we are trying to find the root effort, which is defined as a maximum absolute difference between any consecutive cells. And we want to return the minimum effort here. So for example, 13535, the minimum effort here will be 2, since the absolute difference maximum will be 2 here. And if we go from 1 to 2, 2 to 2, 2 to 2, 2 to 5, in this path, the maximum absolute effort will be 3 because it's kept by 5 minus 2 or 2 minus 5 absolute. So first of all, to this problem, we can think of the DFFs in this first look. Because if we are using a DFS, then for each cell, we have to decide whether we want to use this cell or we don't want to use this cell, which is the time complexity will be 2 to the n if n is the number of cells, which is not acceptable. We have to think of a method that we can go through each cell in just once. So this is remind us about the minimum spanning tree, which is we can use a BFS and a priority queue to maintain this BFS. So if we are initial queue here and we maintain the priority queue by the current max, this is a current max means the current maximum absolute difference in this path. And if we ever see a node, for example, the node 5 here, we don't have to go through this node again, since, as you know, first time we see a node means from the start to this node, we have the using the minimum effort. That's the reason why we're using a priority queue to maintain it. So in this way, we can go through each node just once. If we ever meet if we first time meet the the last corner here, which is 5, then we directly return the current max. And if we ever seen this node before, we just do continue. For each node, we have to see the or consecutive nodes of it. First of all, we have to make sure the node is valid. And to maintain the heap queue, we are calculating the current diff, which is whether it's in this path, whether it's a current max or not. And we define as a current diff and push it to the heap queue. So the total complexity will be n times log n if n is the cardinality of the node or the number of nodes. The n means we can go through each node only once, and log n means the time to maintain the heap queue, which is heapify. But when we take a second look, we can see the heights here are constrained from 1 to 10 to the 6. The thing is here, the thing here is we can define a height, a constant height here, and for any constant height or for any constant effort, I'm saying for any constant effort, we can say whether this is a valid effort or not. For example, if I give the maximum effort as 5, so then 1 to 2 to 2 to 2 to 5 is a valid path, since we only using effort 3 here. So in this way, we can do a binary search to see which effort is the minimum effort we want. So that introduced to a second method here, which is the lower bound will be 0, or lower bound will be actually 1 here, and upper bound should be 10 to the 6. That's the bound of the efforts. And the only thing for each effort, we want to see whether this is a valid effort or not. If it's a valid effort, means the effort can be smaller, then the right equal to mid. To find whether it's a valid effort, we can either using a DFS or BFS. I'm using a BFS here. And one thing I have to mention here, the reason why we give a fixed effort is we can determine whether we can find a valid path using this effort by going the whole graph only once. That's the key idea here, which is how can we make sure that for each node we can just go through it once. So using DQ to maintain it, once we can see that ij equal to the mn, which is this node, then we can return true. Otherwise, we cannot meet the last node, so we will return false here.